Derivatives in base A. Derivative of a to the x is natural log of a times a to the x. Derivative of log base a of x is 1 over x times the natural log of a. It takes just a second to prove these, so I think it's worthwhile for us to do. What is the derivative of a to the x? Where does that formula come from? We know how to take the derivative in base e, so let's write this in base e. I'm going to change the base from a to the x to e to the x. A to the x is the same thing as e to the natural log of a times x. If that's confusing to you, think of it like this. The natural log of a should just tell us the number, the value, that we have to raise e to make a. Does that make sense? Natural log of a tells us what value we have to raise e to make the value of a. From yesterday, 2 to the third is what? So log base 2 of 8 should be 3. It's the same property, but in more general terms. The natural log of a is what value I have to raise e to make a. So e to the natural log of a should just still be the same thing as a to the x. So I change the base to base e. Let's take the derivative of e raised to the natural log of a times x. Well, wouldn't that just be the same thing? E to the natural log of a times x, because in base e, it's its own derivative. And now I have to multiply times the derivative of that exponent. The derivative of natural log of a times x, well, the natural log of a is just a constant. What's the derivative of 5x, for example? The derivative of 5x would just be 5. So the derivative of a constant times x should just be that constant. The derivative of what's in the exponent, the derivative of natural log of a times x is just another natural log a. Let's put this back in base a. So I'm going to replace e to the natural log of a as a. That's why I have basically that formula up here. I change it back to base e because I know how to do the derivative in base e. Take the derivative and then write it back in base a for my final answer. If you have a differentiable function, say I have a raised to some other function in terms of u in terms of x, its derivative is the natural log of a times a to the u times u prime. That is going to be the formula here in number 12. I think these are more useful because typically you have a constant raised to some other function, like 3 to the 2x, for example. Rather than just 3 to the x. Take the derivative of. Let's also see how the derivative of log base a of x gets put together. How do we prove or derive the formula for log base a of x? Well, once again, let's change it back to base e like I did with the exponential example. I'm going to change this back to a natural logarithm. We're writing it as the natural log of x over the natural log of a. Change the base formula. I can change the base to natural log by doing natural log of the big number divided by natural log of the small number. ln x over ln a. Let me write that a little bit differently. That's 1 over the natural log of a times the natural log of x. Let's take the derivative of this now. 1 over natural log of a should just be a constant. The derivative of a constant times the derivative of a constant times a function should be the derivative of that function times the original constant. Take the derivative of a constant times a function, multiply that constant times the derivative of the function. What's the derivative of natural log of x? What's the derivative of ln x? Bring down the constant, and I multiply it times the derivative of ln x, which is just 1 over. Multiply this back together, 1 over x times the natural log of a. Now it matches this formula over here. change the base to ln, change it to base e, make it a natural log, differentiate your answer. Or this formula is coming. If I have an inner function, if I have u being a differentiable function of x, derivative of log base a of u is u prime over ln of a times u. I just multiply times the derivative of the inner function. So that would be this formula. Here, number 11. 12 and 11. Exponential functions in base a, log functions in base a. So let's just try a couple of exponentials. Okay, so as I'm first starting to use these formulas, I think it's helpful to write down everything that we're given. What's the base? So let's call that A. I'm in base A. A is 5. That's the base of that exponential. What am I raising 5 to? What is the u in this case? That's good. Well, if I define u to be 3x, I'm kind of bound and determined to find what u prime is. What is the derivative of 3x? Now I've got everything written down. Let's just use our formula to put it all back together. Natural log of a times a to the u times u prime. So ln 5 times 5 to the 3x times 3. Just replace everything in this formula with how we define it over
Hayes, please report to the secondary office. Hayden Hayes, report to the secondary office.
ln a, so ln 5 times 5 to the 3x. Together, f time of x equals 3 natural log 5 times 5 to the 3x. I just group my two constants together. ln 5 and 3 are each constants, so multiply those 3 ln 5 times 5 to the 3x. Try a different one. Well, 3 to the x over x. Let's practice a little quotient rule. Why is this quotient rule? It's top and bottom, right? Low and high. I say the quotient rule to myself. Low d high minus high d low all over low squared. Except one of those two functions, the one in the numerator, is in base 3. It's an exponential function in base 3. So finding this derivative goes something like this. G prime of x equals low times d high. Well, derivative of 3 to the x would be the natural log of 3 times 3 to the x. That makes sense so far? You want to use this bottom rule? Base 3, u is x, so natural log of 3 times 3 to the x times the derivative of x, which is just 1, so that who cares? It doesn't matter anymore. So low d high minus high times d low, which is just 1, all over low squared. Let's see if I can clean this up a little bit. Not a whole lot of work. I see 3 to the x. Actually, let's write this out first. X ln 3 times 3 to the x minus 3 to the x over x squared. Is there anything I can factor out from those two terms on top? 3 to the x, but yes. I can take the 3 to the x from x ln 3, 3 to the x. I can take a 3 to the x from this next term. I think we'd write our answer as this: 3 to the x times x ln 3 minus 1 over x squared. Not the cleanest looking derivatives in the world, but I don't really oftentimes use these very much. You don't typically work with exponentials and logs in other bases besides e. How we coming? Any questions on these? We can try one more log. We've done a couple exponentials now. Okay, let's do that. Log base 3 of cosine x. I've switched from exponential to now log, right? So we're going to use this formula. We're going to use, what is that? Number 11 on your formula sheet if you're looking here. Log base a of u, its derivative would be u prime over ln of a times u. So let's maybe take a second and write down everything we've got from this. What base are we in? What base is the log in? 3. U would be what? Which function? Log base a of u, log base 3 of cosine x is log in base 3, so a is 3. U is cosine x. If I find u, I'm kind of bound in terms of finding du or u prime. Derivative of cosine. Negative sign? What you going to say, Caitlin? I think you do it. Negative sin x? Okay. Watch those negatives. So just kind of use that formula. Now I know what u prime, u, and a are to write my final answer. U prime be negative sin x. Over ln of a times u. So the natural log of 3. Cosine x. Any idea how I could simplify this a little bit? So you just talk about using a trigonometry? Yeah. So I can use what's here, sine over cosine, to make a tangent function. So let's see, we could do negative 1 over ln 3 times tangent x. That'd be the same. Or maybe even just negative tangent x over ln 3. I wanted to write that. Right, yeah, can it just be this too? Negative tangent x over the natural log of 3? The same thing, right? I'm just multiplying it into one ratio. You see that, Shay? Or there's 2. Let's get out some practice.